You can do more than one step. You can move the e to the negative y over. You can, at the same time you're moving the dx over there, that's fine. But what happens when you divide by e to the negative y? Right? What happens when you get that? That's just e to the y, right? You just put on top. So, so when you divide things over, matter of fact, that would work. That would be good to do anytime you have any powers that you're dividing over. Just flip it to negative or to positive, right? So if it's negative and you divide it, it just becomes positive. So really, if you understand that, you could just, well, I wouldn't. You can't do that with the 2. Be careful there. That's no good. I would leave the 2. I would leave the 2 over on that side. I would not divide it over. So this just becomes an e to the y dy. So if you can do that right away, that's good. But if you want to write it that way, that's fine. Then flip it up. Okay? And then you get 2 dx. And then here's a step where we do this. So then now that's becomes pretty easy on that side. And then this is 2x plus c. And then what do you do to both sides here? To get rid of this y in the power, you ln both sides, log both sides, so ln e to the y, which you can kind of skip that step, and then ln 2x plus c. I mean, when I say skip that step, you know, ln e to the y is just going to be y. So it's ln 2x plus c. Okay? And then did they give you an initial condition there?
Yes. Y at 0 is equal to 1.
Okay. Oops. So y of 0 is 1, so we put a 0 in there. So we had ln c equals 1, so that's e. E raised to the 1 is, so c is equal to e. E to the first, I guess. So c is e, so this would be ln 2x plus e. Y equals. Okay? Okay. So 19, what was 19?
19 was y prime is equal to x squared y. And then the initial condition is y at 0 is equal to
Negative 2. Okay, so let me see. It's x y squared plus. Okay. That'll make a difference. Okay, so x squared y, so again, dy over dx. So if I move my dx over there, I'll be left with the dy. Now here's where, you know, you can start doing one step, but 2 steps at once. So divide the y over. Now you could do that y to the negative 1, but we'd rather, when it's a 1 power, right, we'd rather have 1 over y, right? Because then it's going to be ln, right? Only when it's the first power. But if you have some other power, if you're dividing that y over and it's a squared or it's a fraction or something like that, you know, then just make it a negative power or vice versa. Okay, anyway, you got your x squared there and you got your dx there. Okay, so the dx goes over, that comes there, so we get this. Okay, so now we got ln y. Absolute value bars really aren't going to matter for us right now, so I'm not too worried about that. Technically, they should be there, at least for this part. Now we do e raised to this, so we get y equals e raised to the 1/3 x cubed plus c. So this is that one we split apart. Remember, 1/3 x cubed, e to the 1/3 x cubed times e to the c. That just becomes like an a. So y equals a e to the 1/3 x cubed is a pretty good way to write that. Now we put in our initial condition, put in a 0, we get e to the 0, which is 1. So we'll get a equals negative 2. So we get y equals negative 2 e to the 1/3 x cubed. Like that. Okay? All right. We're going to practice a couple more of these. Let's look at 30. 30 is, what was it? Y prime equals y ln y. Like that. Okay, so dy over dx, yeah, so it looked like we were struggling on that as I came around, or else we just had answers, maybe from our calculator possibly, but maybe you got to figure out. But that has 2 y's in it, so that whole thing's going to have to divide over. So you're going to end up with 1 over y ln y dy, and then you got nothing left over there, so you got a 1. So it seems like it's on its last leg. It and me both. All right. So anyway, so go like that, and then of course this side is not bad. X plus c. I mentioned it a minute ago. You have to do u substitution. Okay. Now I think there was a time we could all do this. That time might have been Wow. But now that I've said it, do you see what it would be? Let u equal what? ln y, right? Because du is, you remember the whole point of picking a u was so the du, the derivative, was setting right there. So if you let u be ln y, you got 1 over y dy setting right there. If I will tell you this tomorrow on the quiz, if I put one of these on there, I will say, hey, show your work on the antiderivative, even though you have the calculator. Now, here, there's no work to show. You just, whether you did this you get this and you get this, whether you do the calculator or not. If you typed into your calculator 1 over y dy, you'd get this. If you type this into your calculator, you get that. If you did it in your head, you would get that. So there's no way I can tell from your work whether you did it in your head or you did it in the calculator. Same thing here. Now, it could be if you had 1 over e to the negative y sitting here, and then all of a sudden you had this antiderivative. Maybe you did that in your head, but maybe you didn't calculate. So it's possible. So chances are when we get to this part, it's going to be, just more like 18, more like 19 probably. Maybe a little more work in the getting the y by itself part, and that's something we got to talk about. I want to do one here where we talk about today. But here, clearly, I would be able to tell. But if you went right from here to the antiderivative, obviously you typed that in a calculator. And if I don't want you to, I'm going to say, hey, show your work on doing your antiderivative. Okay? Chances are we're not going to do that. If so, maybe one problem where that happens. Okay? But you would certainly have your calculator to check if you want to. So that's turns into 1 over u du, because that's all setting right there, which is ln u, and then you get this. So it ends up being on this side, you get ln, and some of you noticed this already, ln y, right? ln y, because this ends up being ln u, right? And I could have absolute value bars around this whole thing, but again, it's not going to matter at the end of the day. So 1 over u, that's ln u. You go back and see what u was, it was ln y, so it's ln of y equals x plus c. Now, this is the part then that also the solving part, how do you get from here to the solve? Well, I told you yesterday, you can do a solve on your calculator too, right? So chances are I'm not really going to be that interested in all of this part of it. Can you separate the variables, do all that? That's the part I really want to see in your work, okay? But the way you would do this, you start on the outside, and that's an e. So you'd end up with ln y equals e to the x plus c. And then you'd end up with y equals, and this is another e raised to the x plus c. Okay? It would look like that. Okay? Now, did they give an initial condition of 30? There was no initial condition. Okay? So you can do that. Okay, if you look in the answer book, I think on that one, yeah, they did rearrange it. And then this, remember, this could be a e to the x, so y, and then they have this, they have y equals e raised to the a e to the x, like that. But they also did leave it just kind of like this too. Sometimes, like I said, you get to one where you can't really solve it for y, it's kind of messy to solve for y. Oftentimes it'll get left like that, so I'm not going to be real picky on that. But the initial condition I'm going to want you to solve for, and I'm going to want you to write it in a decent way, and I'm going to show you a few problems of that here in a minute. Matter of fact, let's go ahead and just keep going with that idea. So let's go over to here. So let me have you try this problem right here. Go ahead and try this one. So it's a little bit like that one we did, number 19. All right, let's take a look at this much of it anyway. So this is what I was talking about with the y squared. So you divide the y squared over, but you could just write it y to the negative 2 as soon as you put it over there, because when you do the antiderivative, you're going to want to do power rule. ln, remember, is only when it's y to the first, or x to the first. It's 1 over y to the first. Okay, 1 over x to the first. Then it's going to be an ln. If it's any other power, then you're going to want to write it as a negative like that, power. Okay. Now again, partial credit and everything is a good thing here because you got this negative 1, so I wrote this as negative 1 over y. And then what I did here is just, okay, I could multiply the y over there, that's fine, but I just flipped this, right? If you got 1 over y equals that, then y would equal the reciprocal of that. So I just flipped the whole thing. I think that's the easiest thing to do when you have 1 over y on one side, because that could happen. So if you get 1 over y on one side equals something, just turn it to y equals the reciprocal, just flip the whole thing. And then, now, it would be okay to leave this like this. It would be okay to leave that. I'm not going to get picky about the fractions, but sometimes then if you're going to work with it, you might want it a little better. So you could take the top bottom times 2. Take the top and bottom times 2. Now what I did here, take this times 2, you get x squared. Take that times 2, be 2c, which is just another c. So I went ahead and left it just c. But and you can put 2c if you want to. Wouldn't really matter. Okay. So that's something I want. Want to make sure you see. More so for the finals where you'll have to do this in a no calculator kind of situation. Tomorrow, if worst came to worst, you could type this in and tell your calculator to solve for y, and it would rearrange it for you. Okay, but now we got to put the 2 in and get out a 4, and that's where then this starts to get a little bit messy. When you put a 2 in here, you get 2 plus c, put the 4 over here, right? Multiply the 2 plus c over to there. So I ended up getting c equals negative 9/4. Now remember, I went back to this version, So you have that, so could you leave it like that? Sure. Okay. Then I showed what it would look like if you use this version, right? If you use this version, remember my c was different. I remember 2c turned into just a c. So then on this one, I got c equals 9/2, and it looked like that. Then and then what I did is took top, bottom times 2. If you want to clean it up a little bit, it could end up looking like that. So I mean, it's like 1, 2, 3, yeah, I mean, all these different versions you could end up with. Same thing on this one. If you take top times 4 and bottom times 4, right, you would get that right there. That would be the same. Okay, so that's just, most of that is just rearranging and, making it look a little nicer, not a huge deal. Okay, okay, so let's see, we had 2 packets. And then we're going to review our notes for our quiz real quick. So we had 2 packets, 2014 we did yesterday. So grab the 2016, grab your 2016 packet. Okay, 2016. And I think it was number 4. 2016 number 4. You might be. Where would I put that? You don't think I gave you that back the other day?
No. Isn't it the one that I just gave you?
No, that was 2017 and the second. 2014, 16, and sample 3. Yeah. Yeah. Those are the early ones. Okay. So 2016, I know we've had so many, it's hard to keep going. 2016, number 4, okay, part C. Why don't you go ahead and do that? Okay, it says find the particular solution to the given differential equation with the initial condition f of 2 equals 3. here's what I got. So divide the y squared over there is y to the negative 2, multiply the dx over there is 1 over x minus 1. So you got an ln on this side, ln of x minus 1 plus c. And then again, same thing we just saw in that last one. Negative 1, divide by negative 1, right? So I divided the negative 1 over here, made the ln negative, the plus c can stay plus. This is 1 over y, so just flip everything. So y would be this all flipped. Make sure you put the plus c down at the bottom. Flip this whole thing, okay? And the negative, since it's negative, we can just put that on top. Then I went in and put my condition in here, so 2 minus 1 is 1, so ln1 is just 0. So negative 1 over c, so c is negative 1/3. Plug the c back in. That. Let me see a problem with what I did there. Then I said if you want to multiply top and bottom by 3 to get rid of that fraction, you could, but not necessary. And it wouldn't be on the AP test either. And I think this was a no calculator one, so it wouldn't be necessary to get rid of that fraction. You could leave it like that. Okay, so we have a lot of examples, and I've got some more in the package you still have that we haven't handed in yet, which aren't going to be due till next week. I'm thinking the 2015 free response we might turn in on Monday. We'll make a note of that. 2015 free response, and you're going to have some work time later in the week, Thursday, Friday, going to be a lot of work time days, okay? Friday for sure. Now I'm probably going to give a new sample 4, we'll have some sample 4 work time. Thursday probably for sure, one of those 2 days. And then there may be a new free response thing, or new set of problems just to kind of take us into next week. I think, I don't know. Yeah, so we'll get into some new packets, late in the week or into next week. We'll still have that sample 4, so we'll still be working on that. And then the first of our finals probably might be next week. Late in the week. If it's not, it'll be the very first part of that next week for sure. But we'll spend a number of days, really starting to review. It seems like we reviewed a lot, but I mean, there are some concepts we did that one packet that had a lot of max min stuff, so we have to do that. We've done a little bit of differential equation stuff, so we need to do more of that. But some more of the stuff from last semester, I think we need to get into a little bit too. All right, so quiz tomorrow. The things that we need to be able to do for the quiz. Let's go back here. So most of this stuff's on your notes, so it's up to you if you want to. I don't know that you want to write any of this down. Maybe some of it a little bit here. Okay, so we started out in 7-1 with area between curves. And remember, top minus bottom, right minus left. And that was all just about height times width, right? Top minus bottom was the height of the strip. The dx was the width of the strip. Height times width is the area of the strip. Integral adds up the area. And that's how you get area. So that's where the strip came from, the whole idea of the strip. And then the length of the strip. Okay, and in the beginning of the semester, length of the strip just meant the length of the strip, right? And the dx was the width of the strip, or the beginning of this chapter. So length times width gives you area. So you had the area of the strip, that was the dx, was the width of the strip, and then the integral adds up the area of all the strips. So simple. But that idea of the strip really led us into the length of the strip. That really led us into a lot of things that in this chapter where we said, oh, that strip could be different things. The length of that strip could mean different things. As we got into volumes and, and all that kind of stuff. Okay, then we also had length of the curve. We haven't done any of those. I got a worksheet for you to work on today with review of all this stuff. Okay. And length of the curve is on there. And so remember that was square root of 1 plus f prime squared. 1 plus f prime squared. So if you're doing the length of the curve f, you have to do the derivative square it and stick it inside that square root with a +1, and then just do that integral, and that's the length of the curve from A to B. So that's probably one you're going to have to memorize a little bit. Make sure you memorize it, and so you can use that when that comes up. Going to be very straightforward. I'm sure it's just going to be what's the length of this curve f of x from here to here, right? So if you know the formula, but real easy to set. Okay? A big part of the quiz is going to be the volumes, right? Because that's what we spent a lot of our time on. Okay? So we had volumes by slicing. So the area, so what we wanted was the area of a slice. So we had to imagine what a slice would look like, and the strip that we drew was some part of the slice. So it was either the radius of a circle, or we drew two strips and it was the outer and inner radius of the circle. Remember, that always comes from the center, the axis of revolution. Okay? And so we had two strips, one was big R, one was little r, and we put it into that. And then that gave us, and remember the whole concept is area times thickness. Dx was the thickness of our lemon slices. Area times thickness gives you volume. Area times thickness gives you volume, and the integral adds up the volume of all the infinite slices. Okay? And then what other slices could we have? We could have a base. We could have a base region, and we could have slices coming up off the page. So we could have squares. We could have equilateral triangles. We could have semicircles. Now, that's not the formula we used, was it? We changed that. What did we use? 1/8 pi d squared, right, was the formula we used. 1/8 pi d squared. Okay? And so our strip was the semicircle diameter. Or our strip was the S, the side of a square, or it was S or B. We use sometimes the base or the side of an equilateral triangle. So as long as you know the area of the slice, you just stick that into the integral, and that gives you the volume. The integral then gives you the volume. Now, we had an alternate version for the top two, right? If you had a disc, circle, or a washer, because it was a revolved solid, so you have these circle type slices, you could do shells or the layers. And that was 2 pi times p times h. Now the 2 pi we typically kicked outside. And p was the distance from the strip to the center, and h was the length of the strip. Okay? And remember, p always looked like, p was always 2 minus x, x minus 3, y minus 0, 2 minus y. You know, it was always something like, p was always something like that. Okay? Distance from the strip to the center. And the strips were always parallel to the axis of revolution. Unlike over here, the strips were always perpendicular to the axis of revolution. Okay? We're going to have some problems in the worksheet to do with that. Okay? All right, so a lot of those kind of things. All right, let's see what else. All right, so, and then this was the box I'd made with that. So the volumes of revolution, shell was kind of an alternate to those, and then we had the volumes on a base. Okay, that's just kind of how I organized those. Okay, work. Okay, so don't worry about this part over here to the right. So we had the spring. So we had the spring. So we had the spring problem. Force equals k times x, that's Hooke's law. And then the integral is just your force, pounds times feet. So your force equation goes in there. And then we had the bucket and the rope and the water, which was the pounds. And then how do we do that if you had a 20-foot well and if the rope was 8 pounds per foot or 0.8 pounds per foot? If you had 20 feet, that's 16-pound rope. So the rope starts out being 16 pounds and you subtract 0.8 pounds for every foot. So that's one way to write the rope equation. The other way was to just put ordered pair. You know, at 0 feet, it's 16 pounds of rope. At 20 feet, it's 0 pounds of rope. And you just work out your equation that way. that was, but basically you come up with that. And we also had the same thing with the bucket. It starts out a certain amount, and it loses so much per foot, so much, I mean, pounds per foot. You could write the equation that way, or you could set up an ordered pair. Okay, and we're not going to worry about that. We're not going to do that thing. Okay, so that's what we did with work, foot pounds. So it's going to be one of those two, or maybe both, one of each, maybe, but it'll come right from those. Okay, and then the last thing we did was separation variables. Now, we already worked this problem earlier, but I did write up there at the top, these are ones that you could practice. I think there is one, oh, I know why I had that other screen up there, or why I wrote this on the board. I kind of forgot why I wrote that up there. Now, remember, on the worksheet today, there's a problem. But it's actually the problem we did, I think, in the 2014 packet yesterday. That's where I got it from on the review sheet. And so we already did it. We did it yesterday. So if you want a new one to do, I've got this one right here. This was from, I think this was from, oh, this is from the 2017 packet that you guys already handed in. We had skipped it. Okay, and I haven't looked through those yet, so I haven't given that back. So if you want to do that instead of the one that's on your worksheet today, I've got it worked out so I can show you that before you leave. So the one that's if you want to do that one instead, since we already did that other one on the worksheet, you can do that. Okay, and then I'll show you the answer. But anyway, those are packets you do have in your possession right now. Sample 3, and you know what? I think. Oh yeah, because we did the 2016 one here. So yeah, sample 3, sample 4 you have. There's a couple of separation variables in sample 4, and then 2015. So those packets you now have that we're going to be handing later, sample 4, 2015, you now should be able to do everything. Shouldn't have to skip anything on those. Okay? All right, so let me give you this worksheet. I've got the answers worked out up here. So, all right. So again, answers here, again, best thing to do would be to check these after. On some of them, if there was an option, if I could do disc or shell or washer or shell, I did them both on here. If there was one just obvious way to do it, then I did it that way. And remind me at the end of the period, I'll put up the answer to this differential equation on the board. So if you look on the back, the very last problem, that may look familiar, right? That was from the 2014 packet. We did it yesterday. Okay, if you want to do that one again, fine. If you want to do this one on the board, that's from the 2017 packet, and I've got the answers worked out that I'll put up there later.